Let me wipe the cord with you.
Yep. And if
And
you're
let me
already, I'm
post
ready, by
the
the way. I think my stream is sharing.
You post your data? Okay, cool. I'm gonna
It's
post. I'm
literally
gonna
in
post
the
something from.
stream share. You see it?
I'm looking at it now. Yes.
All right.
Oh, you're doing
So
screen share? Okay.
that's right. So this is what I did. There's a website. I believe I have the site linked in here, but that's not so important. Anybody can find it. But there's a website that shows when where the sun is at the subsolar point, and the subsolar point simply means the sun is directly, underneath or over that point on the Earth. So what I did was I found the clear enough sunny day. I found when the where the subsolar point will be, and I actually took this simple device where I just simply found the box, and I took my little astronomy notebook. I have an astronomy little notebook where I go out and I make diagrams of stars or whatever I'm observing and things like that. So I took my astronomy notebook and I set it up on the box in such a way that the angle of the notebook was flush so that I can draw a straight line on the box. And I simply took the angle of the sun and drew a line on the box where I can measure that line. So that's pretty much the setup. I didn't think to take a picture of it. It was just me, so I probably couldn't take a good picture of it anyway. But that's what it looked like. But I did take a picture of the box and notebook. That's the actual box and notebook I looked at right there. You probably can't tell, but it says astronomy on the little zoomed in part. If in a little box there. So what I did was after I got that data, I did measurements and calculated the angle and the lengths of everything. And if I was to put it on a flat Earth, it would look something like this. I'll get to that in a moment. But since we know
Wait,
that the sun is, I'm sorry, go ahead.
is there any assumptions about light rays in this about them being parallel?
No, there's no assumptions about light rays. The distance to the sun has been measured by, for instance, radar measurement. So we know that the sun is about 93 million miles away. Um,
Okay, so
Given that,
you're taking that assumption into account, correct? That was
no,
a correct measurement of the
no,
distance
it's a
to the sun.
measurement. So there's a difference between the measurement and an assumption. So if you have an
But
assumption, that means you don't have any evidence for something, you don't have any backing for
no,
something. And go ahead.
sir, you're assuming the methodology of how you measured the distance to the sun, it gives you an accurate measurement.
Okay, so please let me know how it's an assumption, or give me I'm willing to be informed on that.
I'm not.
Well,
I don't know
I wasn't.
everything about that methodology. I'm just saying you're putting a lot of stake on that methodology. You're putting
I
a
can
lot of
How
explain.
faith in
was
that
how was
methodology.
the
Well,
distance to the sun measured?
It's been
well, let's
measured
look
a
at
couple
this.
different
So
ways.
you said on the one hand that I'm making an assumption, but then in almost the same breath, you said you have no understanding of the methodology. So it doesn't seem you're in a position to tell me I'm making an assumption if you don't even know what it is you're saying I'm making an assumption about. But why don't we let me just get through the presentation first, and then we could talk about it some more. But like I said, and somebody had asked a moment ago, my understanding is that they simply shot radar at the sun and was able to, they shot and was able to time until they got the signal back, and then we know the
That
Was
is
speed of
that a
light.
straight
correct.
line? That was
Yes.
a straight line, and it
Uh,
traveled 93 million miles. How far away was the Earth from its original point in space to where it was at when it received the radar back? Like, how far away did they have to put the receiving
How could you
signal from?
possibly get radar back from the sun?
That
Yeah,
That's a
you're
you'd
good
have
talking
to
about
question.
you'd
8
have
That's
to
a
minutes,
six
right?
shot.
you'd have to
So
go look up the reports on that. I don't know all those details. I just
So
I
have a
can
you don't
general
know the
understanding.
methodology either. Is that correct?
Yeah,
I
Yeah,
Pretty
they
I
that's
much.
why
used
under
we were.
I
500.
under
They
If,
used
if,
500
Guys, can we
kilowatt
stop clipping
radar
each
beam.
other, please, one at a
Yeah, I
time? It's
understand
chaos.
all of this. So if you guys think it's not possible, we can talk about it after. But
that sounds
it's
good.
totally possible, and it is what they measured. And real quick, there are other ways of measuring the distance to the sun, such as the transit of Venus, and they all agree. So
But
That's right.
but you do agree if you shoot radar at the sun, by the time that you receive that back from the sun, the Earth is going to be like hundreds of miles away from
yes,
where it was, right?
yes, and
Okay.
the radar wavefront is well big enough to reach the Earth.
That's a six shot, bro.
It's
So we
not
could
a six
disagree.
shot.
We could disagree on that, but suffice it to say that utilizing the idea that the rays from the sun, because they're so distant and so large, are nearly parallel, you could do this math here, and as you can see, I was able to calculate from these angles the radius of the Earth, and therefore calculate the circumference. All the math is on my site. Just go to my site and search flat Earth, and it's all there. Like this is literally like the page that's there with all the math. So basically, what I did was I was writing with a little ink pen, and I noticed that my little mark, it wasn't quite exact. Again, I wasn't using like some high tech equipment. It was literally just a box and a notebook and an ink pen. So what I did was I sort of used the outer edge of my mark and the inner edge of my mark to get a sort of range. So basically, the bounds of my mark would be between a 39,000 kilometer and 38,000 kilometer circumference to the Earth. So what I did was I went to the NASA site and I got their data for comparison. So the radius I got was between 6,300 and 6,100 kilometers. The official value is about 6,300 kilometers. And my circumference was 38 to 39,000 kilometers, and the official is between 39 and 40,000 kilometers, depending on if you're talking about the equator or the pole. So I would say that with the box and an ink pen, I got a pretty good result. What I also
Can you
did
go
was
back
I
up so I
compared.
can see your math?
Say again, please.
Can you go up a little bit so I can see your math?
Certainly. But again,
Thank
it's on the. I could put the link as well. I guess I can't put the link now because I don't know if it'll let me post while I'm streaming. Let me see here. The link is going in
So,
the live stream, so if anybody want to actually go there and scroll for themselves. But yes, but I'll scroll so we can take a look
Hey,
as well.
real
So
quick,
like,
Daryl. Before I just dropped something in the live
go ahead.
stream voice text. I just dropped something. It's a GIF in the live
Whoever
stream
was
voice
talking,
text.
you clipped.
And yeah. Just before it gets too far up in the scroll with other people adding stuff, just check out what I dropped in there. It's a scaling and variance.
Hmm.
So not only are you assuming that the whatever they claim to have set to the sun and back, is correct information. It's not just like reification information, but you can reify it anyway with the math. It shows how it could be any number of distances with your angular size. It just works that way. It's a
And I
transform.
apologize,
So
you cut
none
out.
of
I
the
heard you say
93 million miles.
reify, and then there was a blank spot, and then there was angular size. What did you say in there?
If it's a reification, right? You can put whatever numbers you need in there to get your 93 million miles if that's what you desire. You can make it a number of different distances. There's a scaling and variance. Check out the GIF I put in the live stream voice text.
Okay, let me take a
did
look
you
and
use,
see.
so you use trigonometry to measure the distance to the sun?
Oh, no, I didn't use trick. In other words, this process had nothing to do with me measuring the distance to the sun. It was simply recognizing that the rays of the sun are nearly parallel, and therefore, like if you look at the image that I'm scrolling at right now, the left side is the subsolar point. That's the subsolar point on the Earth. I don't remember the exact name of the location, but it's up in here somewhere. Uh, where was
Did you
it?
do this measurement with the full moon ever?
No, I didn't do it with the full moon. I don't know how that will work with the full moon, but my idea was to measure the circumference of the Earth. This is actually ironically, I took a intro to astronomy class, and problems like this was some of our problems. So I just went out and did it in real life for fun. So it wasn't me measuring the distance to the sun. It was recognizing that the rays of the sun are nearly parallel. Therefore, the subsolar point, which I marked on here as S, is going to have pretty much vertical sun rays. And I'm in Austin, so I'm going to have pretty much vertical sun rays. So that basically gave us the vertical that allowed me to get angles and calculate the distances. So basically, it's just
And
the angle of the sunlight allowed me to calculate the radius of the Earth and the circumference of the Earth. So that's where that comes from.
The angle
I
of the
understand, but
sunlight at point A.
The point A is where I'm at in Austin.
So you measured an angle using like a stick.
No, I use an actual notebook. So basically, this is the illustration of what I did. So the sun was, of course, it's not the scale, but I pointed my notebook at the sun, so it was flush to the sun. I know it was flush to the sun because I had a box, that box right there. The shadow of the notebook on the box was parallel to the edge of the box. So that's how I knew I had the box flush. And I made a mark on either side of the shadow and along the shadow, so I knew it was flush. So then I was able to use that line to measure my length. So if you look at the illustration there, it says the book, that's the height of the book. The bottom was the length of the shadow, and that became the two sides of my shadow, and the hypotenuse is the actual sun rays. The sun rays form the hypotenuse where the sun came across. So if you look at this curve illustration here, the theta would have been where the sun was hitting the box, and the alpha would have been where the sun was sliding along the notebook, and pretty much the left side there would be the notebook. So I was able to use
So what
trigonometry to get the theta angle and go from there and calculate the radius and the circumference, which is very close to the official
what
value.
was your theta? What'd you get for theta?
Theta was 56.99 degrees, and I went from there.
And how far away were you from the subsolar point?
The subsolar point, I was
I think you just passed it.
scroll.
So
It's
23,
somewhere here. I just don't remember off the top of my head.
right
What
there, 2230.
2,230 miles or 3,588 and 67 kilometers. So all the data that's needed to recreate the calculations is there in the on the page. If I made a mistake, let me know. But I went over it, so I'm pretty sure that I did everything correct. So I'm used to working in meters, being that I'm a budding physicist and astronomer. So I converted the miles to kilometers and got 3,588 kilometers from here to the subsolar point, and went from there. So basically,
Okay,
the
Did you say you're a
3588 would
physicist,
be the
Daryl?
arc on the Earth.
Sorry to
Say again?
interrupt. Sorry to
Say
interrupt.
again?
Did you say you're a physicist?
No, I say I'm a budding physicist. I'm an undergraduate student right now. I'm in my senior year of getting my physics and astronomy degree. So basically,
Oh,
it's
cool.
part of what.
Cool.
Go ahead.
Okay,
so
congrats. Okay,
I
I
just
just
used
wanted to clarify. Nice, nice.
Thanks.
I just
Yeah, I
used
have
your
two associate
numbers.
degrees, but I'm working on my bachelor's.
I just used your numbers using a different method, and I got a circumference of 25,309. So pretty spot on, math wise.
Thank you, sir. Appreciate it.
Yeah, man.
Yeah.
What circumference did you end up with in miles?
Well, he did miles, is my understanding. I did kilometers, but what he's saying is equivalent. Now, this is the thing. I also did this. I also tested the same data on a flat Earth. So what I did was I did a flat Earth comparison. Actually, prepared this for the debate I was about to do, but
Wait,
whether the
where'd
flat
you get
earthers
the
didn't
flat
accept the
Earth
report
model?
or what have you. Huh?
Where do you get the flat Earth model? I don't understand when you guys are like, we also did this on a flat Earth. No, there is no flat Earth model. So why? How? Like, I don't get it.
Okay, well, like you said, there is no flat Earth model, so which is very convenient for people to say, well, we didn't give you a model, so that's wrong. But flat Earthers
Well,
generally agree that the Earth is flat. So what I simply
yeah.
did
So
was,
with a dome of perspective, right? So did you incorporate that? Did you use the curve visual space? Did you use the Walter Bislin model? Because that one seems to be closest to accurate.
The Walter Bislin model doesn't produce a methodology for using perspective. It absolutely doesn't do that. What it does is it says your visual space is created on the fly every time you look up, and where those things actually are doesn't really matter because the light will move however it needs to get to you in a certain way.
That's what the celestial sphere is.
That's what you
Go ahead and
believe
Google
it to be.
celestial sphere and read the Wikipedia page. It's like you've never done it.
Well, I've done it, and that's not the same thing. So that Walter Bislin is
It
not
says a
using
point in space, bro. When you're looking up at the sky, it has nothing to do with the ground under your feet.
So you can say that, but that's actually provably not true.
I'll read it in the chat. I put it. It says, all objects in the sky can be conceived as being projected upon the inner surface of the celestial sphere, which may be centered on Earth or the observer.
Sure, that's true. But if you take what Walter Bislin is doing, he's not his dome of perception doesn't have you looking at the celestial sphere. What it does is it assumes that there is maybe not even a celestial sphere out there, but that light coming from theoretical stars somewhere, where the celestial sphere would have them be, has to move specifically in weird ways for each observer.
Define weird.
Curving around in these strange, hyperbolic or more than hyperbolic curves.
Why is that weird?
Because as far as we know,
are you saying light doesn't bend? Do I need to post the black swan image for you real quick?
You can post
so
it all you want.
You could go ahead and tell us that light bends in all these weird ways.
Well, Tora, you could do that, but what you could do is you could look at Walter Bislin's actual model and read what he wrote about it and how he shows light bending to make the model work. And you would come to the conclusion that the black swan is nothing even close to what he's doing to make that model work. So no,
a 10 times radius value.
This has the light like doubling back on itself.
I know what he's talking about. This was actually brought up in a debate. I believe it was, I can't remember the guy's name. He doesn't debate too often, but he was debating with Whitsitt, and he had Whitsitt bring up the model. And if you put in different points of the Earth, like towards the edge of the distance from the North Pole, the light pretty much has to go out and loop back in order to reach the angle that it has that we observe in real light. In other words, when you're standing on the Earth, at certain times, sunlight hits you at a certain angle, and according to the model, light would have to go out and bend back to hit your eye at that angle, given to where the stars and the sun and everything is at. But suffice it to say, like I understand that you're saying that there's this model. As I mentioned earlier, I'm a budding physicist, so I'm definitely not an expert physicist, but I've had to do labs on optics and things like that. I have a basic understanding how light works. So I'm basing my understanding of light on my practical experience and understanding of how light works. So if the Earth is flat and light is coming from the sun, then this is what we'll be looking at. You all may not agree as flat earthers, but based upon my understanding of the way light works, it's not bending all like crazy and everything like that. So this is what we would be looking at. So given
Wait,
that the
sir,
Earth
if
is
I
flat,
pull the black swan image, are you not going to say that light's bending in a crazy way?
No,
no,
not in a
I'm not
crazy
going to
way.
say light is bending in a crazy way. So I've already seen
Well,
videos
in a
on
way
that. If
that
you
is
haven't, look it up.
non-demonstrable. In a way
Okay.
that you cannot demonstrate, right? Like if we were to, like, for example, someone tried to demonstrate with a propane tank the other day, but that didn't lift the horizon, only the image. So this is the problem: is the ground, the horizon line is what's being loomed in that scenario, according to you, not just the oil tanks, because that whole image is about the horizon line being over 10 miles away from a 1 foot high observer.
Yeah, I mean, I haven't done those calculations and investigations, but I've seen it done. I've seen people do it. So just look online for debunk of black swan or whatever, and you'll be able to see people who do the calculations for that. But suffice it to say, I'm simply looking at the fact that I'm on the Earth. If the Earth is flat and light is coming from the sun, this is what we'll be looking at. So basically, took the distance to the subsolar point. So you can see the little circle I drew. I know some people say it's infinitely straight, or some people say it has a dome, or whatever. I'm just saying that if there's a North Pole, I know how far I am from the North Pole. I know how far the sun was from the North Pole, and I was able to make this happen. So what I did was, now at the time I did this observation, the sun wasn't in this position, right? But what I'm saying
Hey,
is,
Daryl,
right,
one quick second. One quick second.
certainly.
I wanted to show I posted a picture again of how refraction works with the horizon. So, Tora, that is how the light was bending for the black swan. That's not a crazy thing to say. That is how we understand refraction to work. Sorry, go back.
No problem. Thanks. So, so what I did was, now at the time that the subsolar point was going on and I was looking at it, of course, it was daytime in both places. It was daytime where I was at and daytime where the subsolar point was. But what I considered is, okay, if flat Earth says that the sun is going around the Earth in the air, then at some point the sun will be on the opposite side of the Earth, and we know how far away from the North Pole it is because it was right over the subsolar point. So what I did was I took the same distance from the North Pole to the subsolar point, but now I put the sun on the other side of the flat Earth, or it is a disk or whatever. But then I simply calculated how high the sun would be in the sky. So basically, what I found was that the sun would never set. The lowest the sun would be in the sky from where I'm at would be 18 degrees. And the lowest it would be, like for instance, on the edge, like considering like Antarctica as being the edge of the Earth, would be 10 degrees. So suffice it to say, what I found was that the sun would never set, given that
The sun,
the
the
sun
sun,
was at a distance. Go ahead.
You're
the sun's
mixing. Hold
always
on a
above.
second.
Oh,
Hold
sorry.
on. We made a room. Geo has a room, the sun room. There's a sun. It's in the list on the left, down towards the bottom more. Look at some of those pictures of a sunset. It's crazy. Like I don't know if you have access to see that room, or if somebody could just post a few of the pictures or gifs from it. Like sunsets
Sorry,
are
where is it at?
crazy. It's in a room called Sun. It's on the left hand side. There's actually a
Okay,
picture of a sun.
called sun. Okay, let me see. Okay, I see Earth research, the moon, the sun. It's something
Yup,
that
the
was
sun.
posted
That's
recently, or
one.
are you saying it's earlier
Yeah,
posted?
click the sun room, and you'll see
Uh,
all the gifts.
yeah, like you can see some gifs, some videos, some pictures of sunset. I mean, this one setting, it's like a degree, a half a degree above the horizon setting. This
Well,
other
I mean,
one's got devil horns.
to be clear, I'm not saying the sun doesn't set. So I mean, it doesn't surprise me that there's videos of the sun setting. What I'm saying is, if the Earth was flat, the angle of the sun in the sky means that it would never set if the Earth was flat. So the Earth is a globe,
No,
so of course the sun sets because the
Because
Earth
you
is
know, dude.
I,
rotating. Yeah.
hold
So
on. I
Well,
understand. Hold on, man. I understand what you're saying. Yes, the sun would set on a globe, and we know the sun sets in reality. But
mhm.
have a look at what some of these sunsets look like. It's setting. Some of these has the sun setting before it even hits the horizon, like a lot before. Some of them it looks like it's set, and then you zoom in and it's not set. Some of them are just crazy. Just look at what's going on with sunsets. It's not
Well,
it's not the like geometry happening. There's some wild shit happening.
I
Yeah,
mean, not only that, but our angles that you're getting, of course, if we believe we're on a flat Earth and the sun's above us, of course you're going to come up with an angle that is positive because the sun's always over the Earth. We're arguing it's a visual effect. You can't just say, my math says it would never set. We agree with that. We agree that the sun's always over the surface of the Earth. Okay, so coming up with a 9.8 degree when it's on the other side, that doesn't surprise us. We know it's going to be a positive angle, right? So
mhm.
you're just saying, according to my math, this should never happen. We should never see a sunset. But you're also not, when you're looking at a sunset and you're measuring that angle from where you are, right? Who's to say that that's the real angle? You're measuring the angle from the horizon. There's no real
I
way.
think
Like,
it's
this
about.
doesn't change
I think
anything.
it's because he's assuming that the sun is similar size and it would be like always visible. There would always be sunlight no matter what because the sun must be as big as he thought it was. Right? Is that
I mean,
Daryl? Is that right?
you don't have
You
to
Well,
assume.
understand?
I
You
can actually tell
understand a
you what my
close and
position
local
is.
sun.
real quick, I just put
Well,
a
you understand
couple
the
of
flat Earth
gifts of
position
the
is a
sun
close and
in the
local
chat.
sun.
Yeah, please hold
A
on.
close and local
I think
sun
Joe was
wouldn't
trying to
always
ask
be
something.
visible because it's not as bright as you would assume, right?
do
I
we
just
think
posted a couple gifts of the sun in the chat.
do we think that the
Hold
half a
on,
world
hold
gets
on,
sunlight at a
hold
time?
on, hold on. Daryl will just ask the question. Please
Yes,
repeat the
certainly. So
question and Daryl answer.
thank you. So basically, what my position is like. So for one, I'm looking at these sun pictures. Like I noticed that whenever I've seen so far, Flat Earth, this picture mentioned like the sun is doing something strange when it's setting. It's never with a solar filter. So what I did was years ago now, I got my own solar filter and I went out in several places and looked at the sunset, and it always sets bottom up like normal. The second thing is like I'm hearing all of these things
Over
about light
water?
maybe. Uh, I don't remember if I did it at water. I don't think so. I'm pretty sure I did it over land. But suffice it to say, I
You
didn't
said
see.
Daryl, give me a second. There was a question asked to you, which you didn't answer. Could the person that asked the question about assuming the size and whatnot?
It was me. I just said, Daryl, are you assuming that the sun would be a certain size and brightness even over a flat Earth?
I don't recall if I calculated a certain size. I don't think I did. I just looked at the angle of the sun in the sky. That just the fact that the angle would have the sun still in the air. I don't recall looking at any size. Looking over the data again, I don't see where I took into account any size of the sun. Simply the angle of the sun in the
Well,
sky.
I
Yeah,
thought you
see,
said something like that we would never have night time if it was over a flat Earth. We would always see the sun.
Yeah, you cut
yeah,
off where we
because
was
he's
talking.
looking at the angle. He's looking
Well,
at
we
the
always
angle.
see. Are you assuming that we would always see the sun? That the sun would be a certain size and brightness that it would never go away if it was a flat Earth? Or is that what you're assuming?
No, like I was saying earlier, and I could dovetail this into what I was about to say. I have a basic understanding of how light works. Except for some refraction, given it the air conditions, light comes from a light source to our eye. So unless somebody could give some kind of evidence of this strange thing is happening, light is coming from the sun, so that's where the sun is at. So I just got the angle. It's pretty simple, and the sun would
No,
still
it's eight
be
eight
at a.
minutes
Take
difference.
take a look at the chat, dude.
Oh, okay.
Just there's a couple of images in there. The last one I posted is basically what you're presenting: elongated shadows on a globe. But you can have
I
the
mean,
same
basically,
effect on a flat surface with a local sun.
But that's
You
actually not
can't
basically
true.
assume
taking an
the
angle.
size. You can't assume the size and the brightness of the sun,
That's
and
actually
it'll
not
work.
true because that's already been done. Like I only did it with two spots. So my understanding is you can say that with two spots, but there was like the Veritas little documentary that came out showed how the Eratosthenes was done with like 20 something people. And the more people you add, the less likely it is on the flat Earth because the height of the sun is different for more and more people. And if I remember right, MC Toon did this as well.
Right.
He did it with like a group of people. So the fact is, this what you
Dude,
have according to Eratosthenes, this table is
Guys, he's
evolved.
getting.
That's
You guys
not
hear
true
me?
because on the in real life
I
outside
hear
with
you,
their
Jeremy.
actual sun with a flat Earth, the sun would have to be different heights at the angles that we get. Only on the globe in real life would it work with fewer or more people. So that's simply not true. So that's why when I
You're
look at the
incorrect, man.
same
I
numbers,
I
think
think Jeremy wanted to go in.
a lot of assumptions are
Hold
being
on,
made
you
here. But yeah,
guys.
go
Hold
ahead.
on. Hold. Hold on. He's making an angle to the sun and then doing geometry with it. I showed you guys 100 times how to defeat this argument right here.
yeah,
well,
just post the
defeat it.
black
What is
swan, right?
the defeat of the argument?
You're saying light travels in straight lines.
Yes, unless there's something affecting it, it travels in straight lines. That's correct.
Yeah, our
Yeah, your
perspective.
perspective is
So
affecting it.
much
The
simpler
minute
than
it
that.
enters your eye, it changes angles, dude. This is the funniest part to me is this is why I tried to eliminate you going to this argument. I said you don't have the proper model. You have
And I'll
not
stop
taken
sharing.
the perspective dome into account.
He's
So
begging
if
the
it's
question
lower
of bendy light rays.
That's right.
in some
He's mixing models together. It's just a
This is
mess,
the
dude.
thing, Torah. This is the thing. All right. If people who are anybody, I don't think anybody is, but if somebody was looking at my stream, you'll see that I'm on camera, and that camera is a technology that works. And so our technology that we have, cameras, glasses, are based upon the scientific understanding of optics, right?
Yeah, it's a
The technology
perfect
Which has
works.
example.
nothing to do with globe Earth.
No, it's actually a
Well, you didn't
perfect
let me
example.
finish, so maybe that's why it doesn't seem like it's related. But maybe if you let me finish it,
Fundamentally
it
not
could relate.
related.
Maybe
Depending
if you
on
let
the
me
lens,
finish, you
it
might
looks
see the
different.
relation, right?
Right,
So
tell
so the
me
technology,
which lens can actually physically bend an object.
right? So try to hear me out before you retort because you didn't really hear what I was saying. So what you're saying is not related to what I'm saying, right? So the technology works based upon our understanding of light and optics. So that supports that supports that the idea and understanding of optics is correct. So when I apply that understanding of light and optics to this observation, there's no reason for me to believe that there's some kind of strange thing happening when I look at the sun for this observation, when strange things are not happening when we use cameras and lenses and
Have you
things like that. So unless you
here's
could
Wow.
present an actual
Yeah.
scientific understanding where we can calculate and measure and get all the things we can do with the understanding of light that we have now, then I'm simply not going to accept it. That to me is believing or
Okay.
assuming that
Well, then
whatever of these fallacies you want.
What
you're
does
not
light's
understanding
behavior
what
have
your
to do with the
optometrist
surface of
said.
the
Hold
Earth?
on, Elijah. You're
Hold
not
on,
understanding what your.
hold on, man. First of
No,
all,
Elijah
hold
was
on,
going.
man. We didn't even
He was talking to Elijah.
Fine.
just hold. Everyone, hold
He,
on,
he
okay?
asked, and
That's
I
good to know.
conceded
But
it.
hold
Fine.
on a
Go ahead,
second,
sorry.
though. We gotta go, guys. I'm modding. I'm out of the argument. Okay, we gotta go one at a time. No, he didn't even finish his thing. He got clipped multiple times at the end there. Just let's let everyone finish. That way it'll go nice and smoother. Also, please try to be concise.
Yeah, and Elijah had next on that argument. So Elijah.
No, it's alright. I gave the floor to Tora, I think.
All right, Torah.
I think it was.
Yeah, I've totally forgot my point. That's good. Go ahead, Elijah.
It was about the
Well,
light.
To
Go ahead.
me, I understand everything he's saying. You lot, if you had the time and the patience, you could deal with it. But it's irrelevant. The behavior of light, whether he understands it correctly or incorrectly, whether people's correct or incorrect understanding produces functional technology, doesn't change the fact that it's got nothing tangibly to do with the shape of the Earth.
Oh yeah,
We could agree, disagree on that. So
your
Yeah, I don't think.
optometrist will tell you that you can only perceive depth up to 20 feet. So when anything in your vision beyond the 20 feet, you're not perceiving the depth. So yeah, when it moves farther away from you, meaning it's going deeper out of your vision, that will give the illusion of it falling down.
Yeah, but wait, no. What does that mean? So depth
Wait,
is
so
Yeah,
you're gonna
like a
respond, but
traffic
you don't
light.
know what he means?
is depth is different than down.
Yeah, but it gives an illusion. If you can only discern depth to 20 feet, when things or perception look like they're going downwards, just like a traffic light. When you approach a traffic light, it's down in front of you. You go under it, it's above you. You go through it, and it gets behind you. It starts to set. It's the same concept.
Yeah, but if we measure the angle to that traffic light, we still calculate the correct height of the traffic light.
No, you would not.
Yes, we do. It
How do you use
testably
What, using
That's
Euclidean geometry, yeah?
using
No,
a
no, that's not right.
measurement
That's not
using.
correct.
Well, it is
No,
because
because
I get.
your
I,
your favorite institutions, right? The ones that you say you believe, they're
well,
practically doing things today with hyperbolic visual space, etc. That's proving, without any doubt, that that's not how it works. So Euclidean, as a method to describe what we see, is not sufficient. When you include that with the hyperbolic and all the rest of it, they are able to get actual accurate results, and they're using this in robotics and in other type of applications. You can go and look this up.
if only that were true, but
No, it's not. Well, hold on. So what
well,
instead of actually going confirming and looking it up, you're just going to hand wave dismiss. If only that were true.
I've
It
actually
is
got
true.
I've got
It
data
is
for
true.
you
It
right
is
here
true.
that we can look at. We can look at this. I can show you.
Then you don't
that-
understand.
Well, I think maybe you don't understand. So I've just posted a link
What did I just say then?
to data. So what you think is that using
What did I say?
Euclidean, you think using Euclidean math or Euclidean techniques to accurately measure the height of something doesn't work. Based on a visual assessment of it using tools, and I am showing you that is not true.
It's not sufficiently accurate to actually describe what's going on. This is why they're employing the hyperbolic geometry in order to get actual accuracy, because in some of the applications that they're doing, hence the robotic citation that I gave earlier, they need it to be more precise than okay, it's about 2 feet away or whatever. And yes, I'm being hyperbolic in my language to get the point across. Right? But you're clearly not understanding what I'm saying.
So
you don't want to let go of your position, because if you let go of it, then your whole thing falls, right? But again,
Okay,
what
so
does this have to do with the shape of the Earth? How does it change?
I'm
How
gonna
does it
explain
change
that to
water?
you. I will explain that to you. So the way that it works is that we can use our eyes and optical tools like a theodolite to accurately measure the height of an object at range using trigonometry. So what that means is that whatever you think is going on in our eyes or with bending light in the atmosphere or whatever else you want to claim, or some undiscovered element of perspective, whatever you want to claim, the fact is this technique works. I can show you it works. I've got data to show you it works. So, it
So
doesn't
what
matter.
you said, does it diminish what Torah said and what I said?
Well, I think if you're trying to claim
No,
that
it doesn't. No, it doesn't, because
wait,
you're carefully darting through everything we've said. You're not actually engaging in. You're not actually engaging in what we're talking about.
I think
he's got evidence that proves you wrong, Elijah.
Right.
Wait,
exactly.
no, hold on. Proves me wrong. My
Yes.
evidence wasn't my own, by the way. I
You're-
was citing people who are actually doing this, institutions, academic and professional institutions that are doing things in reality. So what did I present that isn't true?
Well, to be fair, you didn't present
Have you actually
anything.
gone and done the effort to test this? Do
Yes.
you actually remember what Torah just said and why this discussion is where it is right now?
I've had this discussion with Torah before, and the conclusion that we came
So
to.
you're
which was an
incapable. You're
agreement-
incapable of learning then.
Well, I'm just capable of determining what's real and what's not. So Torah and I disagreed on whether or not our visual reality is constructed in real time in our heads based on, the light of God or the truth of the universe versus a view of a objective, set of objects, right? They may only be in apparent positions.
All right, so that was that. So I had some data available. I was looking forward to sharing. So glad I was able to get it shared. I think I had the Discord audio a bit louder to start out. Check it out. If so, then I may just upload this and re-upload it with the audio fixed. I'm still working on my audio and getting that worked out, but I'm getting better at it. So looks like I only have one viewer maybe this time, so it won't hurt any live chat because I have to re-upload it. But I'll still be back later to do my what do you call it? Uh, commentary on the Veritas documentary, which is an awesome documentary. So I'll be back this evening. You can see the upcoming stream and see when that's coming. So that'll be cool.